Hey, good morning, gang. Mr. Carey here. Week 2, Spiral Review. You ready to go? Hope you had a great weekend. Let's get to it. Question number 1, ask you to give 2 names for the polygon shown. 2 names for that polygon. Well, remember that when we're naming a polygon, first of all, remember that a polygon is a plane figure. Plane meaning that it's flat. It has length, it has width, it does not have any height. Okay, it does not come off the board. It's a plane figure. All right, it also has straight sides and closed. That's what makes it a polygon. We wanted to give 2 names today for this. Okay, so the first way we name a polygon, the first thing we look at is counting the sides that it has. This has 4 sides, so the first name we should have given it was what? It was a quadrilateral. 4 sides, quadrilateral. Remember that quad means 4, lateral means sides, so quadrilateral was the first name that we should have given. Okay? Now, next, we want to look at the relationships of the sides. Are they parallel to each other? Well, the 2 sides are not parallel. They're tapered inward this way. If they continued, they would eventually cross or touch. What's the name for when sides cross or touch? We say that they what? Intersect. Good. These will eventually intersect if we were to keep going. Okay, so they are not parallel. Parallel lines go in the same direction and never intersect. The top, however, is parallel to the bottom. So this has 1 pair of parallel sides. This is parallel to the bottom. If you have a quadrilateral with 1 pair of parallel sides, that makes it a trapezoid. And that was the other name that we could have given this figure. This is a trapezoid. This specific trapezoid is called an isosceles trapezoid. All right, isosceles, you heard that with the triangles, right? A triangle that has 2 sides that are the same is an isosceles triangle. Well, this has 2 sides that are the same as well. These 2 sides are the same length, which makes it an isosceles trapezoid. You will, however, sometimes see other kinds of trapezoids. What you want to look for is that 1 pair of parallel sides. Okay? So the 2 names you could have used today, quadrilateral and trapezoid. All right, the second part of number 1, draw a line of symmetry on the figure. Remember that symmetry means that we can fold an object so that both sides match. One side would lay against the other. Does this have a line of symmetry? It does. Where is it? Is it a vertical line of symmetry or is it a horizontal line of symmetry? This one is vertical. It's going to go down the middle. I could fold this over, and so this side would look exactly like that side. It has 1 vertical line of symmetry. Let's go to number 2. Number 2 says Mike has 2 toy cars. Link has 5 times as many cars as Mike, or excuse me, it's Miles. I'm sorry, I don't have my glasses on. It helps if I put my glasses on. How many cars does Link have? All right, whenever you have a problem, boys and girls, and it has, it's naming 2 people or 2 places or 2 things, and you're comparing one to the other, okay? It's always good to label on your paper. Always good to put things down, write down what you know, write down what you can figure out, and that way you can see it, and it makes answering questions much, much easier. So the person that we know from our problem is who? We know Mike. Mike has 2 toy cars. So we're going to put a 2 underneath Mike. To find Link's amount, we have to use this information over here from Mike. Okay, this is why we label. Link has 5 times as many as Mike. Not 5 more. If it was 5 more, that would be what you call an additive comparison. If he had 5 more than Mike, it would be 2 plus 5. But that's not what it says. What it says is he has 5 times as many. We're using what's called a multiplicative comparison. We're using multiplication to compare them. We're going to take Miles, I keep saying Mike, and it's Miles. Sorry, gang. Yeah, I'll get it. It's Monday for me, too. All right? We're going to take Miles' number, his 2, and Link has that amount 5 times. So we're going to do 2 times 5. He has Miles' 2. Miles has those 2 toy cars. Link has that 5 times. So we're going to do 2 times 5, or 5 times 2, because multiplication has a commutative property. And that would give Link how many cars? That would give him 10. Okay, that would give him 10. So whenever you have that word times in there, think about when you what math operation that leads us to. We always use the word times in multiplication. 3 times 6, right? 6 3 times, or 3 6 times. That's why we use that word. Okay? So in this case, Link ended up with 10. Miles had 2, Link had 10. All right? Remember, if you have any questions, you didn't understand it, okay, have your folks shoot me an email, and I'll get up with you and we can work it out. All right? Question number 3. It says a prime number has only 2 factors. Now, when you're talking about factors, you're talking about multiplication. Okay? With addition, you have addend, right? Addends, you put them together, you get the sum. Okay? With subtraction, minuend, subtrahend, and you get the difference. With multiplication, you have factors and the product. So, if a number has only 2 factors, that makes it what we call a prime number. And it says in here that the number 5 is a prime because it has only 2 factors, the numbers 1 and 5. 1 times 5 gives you 5. There's no other way to get 5 using multiplication. That makes it a prime number. The number 6 is not prime because it has 4 factors. I can get 6 by doing 1 times 6 or 2 times 3. That gives it 4 factors, 1 and 6, 2 and 3. Since it has 4 factors, that's called a composite number. We'll get to that tomorrow. Okay? So what I asked you to do today was to name a prime number between 10 and 20. Let's take a look first at the numbers between 0 and 10. Now remember, a prime number, and I'm going to write it up here again, a prime number means it only has 2 factors. So let's start with the number 0. Okay? A lot of times people want to say, oh, 0 is a prime number. 0 is not a prime number. 0 is a special number because it has really an infinite number of factors. To get 0 as your answer in multiplying, you simply say 0 times a number. So 0 times 1 is 0. 0 times 2 is 0. 0 times 6 is 0. 0 times 20 is 0. It's an infinite number because no matter what number I make, I can multiply times 0 and I'm going to get 0 again. So 0 really doesn't fit for either one of these things, prime nor composite. Okay? And then people talk about the number 1. Okay? Well, 1 is prime because it's 1 times 1. Well, let's think about it. If you get 1 by doing 1 times 1, the only factor for 1 would be 1. It only has 1 factor. So 1 doesn't fit either. 1 is not considered prime. So we're going to leave those 2 out. But I wanted to address them so you knew. Okay? So now we're going to start with 2 and work our way through 9. Okay? Let's start with the number 2. Think about how you multiply to get 2 as your answer. 1 times 2. Good. Is there any other way to get the number 2? No. 2 is a prime number. Now, what you're going to find about the number 2, 2 is also an even number. It's the only even number that is prime. All the other even numbers will have 2 as a factor. And so they will not be prime numbers. They'll all be composite. 2 is your only even prime. Let's go to the number 3. What are the factors of 3? How do we get 3? 3 times 1. Is there any other way? There's not. 3 is a prime number. Let's go to 4. How do we get 4? 4 times 1. That's 2 factors. 2 times 2. Okay, so 4 actually has 3 factors. 1, 4, and 2. 4 is a composite number. It's not prime. Let's go to 5. We said on the paper that 5 was prime. 5 times 1. How about 6? 6 times 1. 2 times 3. That has 4 factors. That's not prime. How about 7? 7 times 1. Any others? Nope. Now I know what you're thinking. Oh, all the odd numbers are going to be prime, right? Wait a minute. Let's go to 8. Okay? 1 times 8. 2 times 4. That's 4 factors. 8 is not prime. 8 is composite. Let's go to 9. 1 times 9. 3 times 3. 9 has 3 factors. 1, 9, and 3. 9 is also composite. So you can't just look and say, oh, odd numbers are prime. No, they're not. Some of them are, okay? Some of them are, but many of them are not. All right, so our prime numbers between 2 and 10, or between 2 and 9, 2, 3, 5, and 7. Now you had to come up with ones between 10 and 20. All right, let's start with 10. What did you do with 10? 1 times 10, 2 times 5, 10 is, well, first of all, 10's even. And I'm telling you right now, no even numbers will be prime. So we can just get rid of those even ones. How about 11? How do you get 11? 11 times 1. That's the only way. So 11 could have been an answer you had today. 11. 12, nope, 12 is even. 2 times 6. Okay, so that's not going to work. 3 times 4. 12 has 6 factors. 13. 13 times 1. Nope, just 13 times 1. 13 is a prime number. 14, 14's even. 1 times 14, 2 times 7, that's composite. 15. 15 times 1, 3 times 5. 15 is composite. We can't put that one. 16, 16's even. Okay, so that's going to have 2 times 8, 4 times 4, 1 times 16. It's composite. 17. 1 times 17, and that's it. So 17 is a prime number. 18. 18 is even. 3 times 6, 2 times 9, 1 times 18. Okay, so that's composite. 19. 1 times 19. Was there anything else? Nope. 19 is a prime number. Okay, and 20. 20 is even. 2 times 10, 4 times 5, 1 times 20. So your answers that you could have had today, prime numbers between 10 and 20, 11, 13, 17, 19. Did you get it? I hope you did. If you're having trouble, shoot me an email. All right? Number 4. Number 4 says give a mixed number for the shaded amount. Now, mixed number. What does that mean? Well, it's a number that's mixed. How is it mixed? It's going to have whole numbers and fractions. Okay? And you've been using mixed numbers even since you've been little. Okay? Okay, when you were a little kid walking around and you were 3 years old, but you wanted people to think you were older, you didn't walk around going, I'm 3 years old. You said, no, I'm 3.5. Okay? You knew how to take that half and add it on to the whole number. Okay? So when you're between 0 and 1, between the whole number 1 and 0, you're just going to have a fraction. Okay? Because you have no whole amount. But once you pass the number 1, once you pass a whole thing, then when you add a fraction to it, then you're going to have mixed numbers. So you're going to have mixed numbers once you get greater than the number 1. Okay? Between 0 and 1, you have a fraction. Between 1 and everything else, you're going to have a mixed number, whole number plus the fraction. So in the picture you had today, you had 4 squares, right? How many of those squares were entirely shaded? Well, 3 of them, right? 1, 2, 3. So we're going to have the whole number of 3. Because we have this square, that square, that square shaded. Now, we're done with these. Once you did them, you're done. Now go to that one. What fraction is that? Forget this. What fraction is this? Remember, fraction, numerator, denominator. Numerator, the part you're looking for, shaded. Okay, what is it? How many are shaded? 2. Denominator, how many are in the whole thing? Just that one. 3. So this is 3 and 2/3. Now listen to the way we say that. 3 and 2/3. 3 and 2/3. That is your mixed number. Now, tomorrow I'm going to ask you for a mixed number again. I'm also going to ask you for something called an improper fraction. Now, an improper, what does that mean? I bet you've heard that before. Proper is the right way to do something. Improper means it's done incorrectly or it's different from the way it's normally done. Normally when we have a fraction, your numerator is less than your denominator. So an improper fraction will have the numerator that's larger. How does that happen? Take a look at this picture. Every one of these boxes is in 3 parts, right? All right. So every one of them is in thirds. So my denominator, if I'm looking at this, is going to be 3 every time. It's going to be 3. Okay? Now, if I want to make an improper fraction, all I have to do now is count how many of those thirds do we have. Well, how many are in here, or how many are in this one? 3. 1, 2, 3. How many are in this one? 3. 1, 2, 3. How many in this one? 3. 1, 2, 3. How many in that one? 2. 3 plus 3. 6. 6 plus 3. 9. 9 plus 2. 11. There are 11 thirds in that figure. Okay? Whole number, 3 and 2/3, or mixed number rather. Improper fraction, 11 thirds. Let me draw another picture real quick and let's take a look at it. We'll try another one together. Let's see, I'm going to do some circles. Let me do this. Can you see it? Did I make it big enough? I don't know. Let's see. If I did now, mixed number, mixed, okay? How many whole circles are there? Whole ones that are all shaded. 1, and what fraction in the next one? Can you see it? 1/4. So this is 1 and 1/4. Now, if I want to write an improper fraction, my denominator is still going to be what? The denominator doesn't change. It's still 4. Now, each one of these pieces is a fourth. How many of those pieces do I have? How many here? 4 plus 1 makes 5. 5/4. So, mixed number, okay, it's mixed because it has whole numbers and a fraction. Improper fraction, it's improper because your big number is in your numerator. We'll work on it this week. You'll do great on it, I'm sure. Last one. Whew! Last one. It says perimeter is the distance around the outside. Okay? Area is the space on the inside. Okay? Now, if you walk around the room, okay, if you were to get on the wall and you were to walk all the way around the room, you'd be walking on the perimeter of the room. Perimeter goes around the outside of something. Okay? If you were to lay down on the floor, you'd be laying in the area of the floor. All right? Perimeter. When you put up a fence in your yard, where does the fence go? The fence goes around the outside of your yard. It goes on the perimeter of your yard. Okay? When you put grass seed down, where do you put it? You put it on the area of the yard. You cover the yard. Okay? Carpet. Does carpet cover area or perimeter? Carpet covers area. It covers the inside. It covers the inside. Let's see. When they put the ceiling tiles in the room, did they have to know the perimeter or did they have to know the area? They had to know the area. How big is that ceiling? They had to know that. Okay? Get the idea? All right. So, to find perimeter, you simply count or add your way around the outside. You pick a place and you start. I'm going to start here in this corner. How far is it across that top part? It's 1, 2, 3, 4 units across. So I'm going to put a 4 there. Now I would turn the corner. I'm going to walk down this side. How many units down that side? 2. Now I'm going to turn the corner again. I'm going to walk on this side. It's 4. And I'm going to turn the corner again and walk up there, and it's 2, and now I'm back to where I started. So if I go all the way around the outside, I walk 4 units, 2 units, 4 units, 2 units. Now, if I want to find out what that total is, I have to add them. Okay? 4 and 2 is 6. Now I know here again I have another 4 and 2, that's another 6. 6 and 6 is 12. Your perimeter was 12 units. Now, when you're measuring perimeter, you're measuring length. So usually your units will be named like feet, inches, yards, miles, centimeters, meters. Okay? But in this case, if there aren't anything, we use just the term units. So, 4 units, 2 units, 4 units, 2 units, and I add my way around. That gives me a perimeter of 12 units. Now, how do we find the inside? You'll notice it says area is given in square units. For the inside, we simply want to count how many squares are there. That's what we want to do. We want to count the squares. Okay? So, I have a top row. How many squares in the top row? 4. How many squares in the bottom row? 4. 4 and 4 is 8. It has an area. Now watch how we label area. 8 square units. Now again, once we have a unit like feet or inches, it might be 8 square feet or 8 square inches, but we always want to use SQ, square, okay? So the area is 8 square units. Now I want to show you something. When your figures get bigger, you don't want to sit and count all those squares, okay? What we can do is we can use multiplication to help us find area. Okay? Perimeter, you have to add your way around. There's no getting around that. But for area, we can shorten it by multiplying. If we know 2 adjacent sides, adjacent means they're connected. Okay, they're next to one another. This side is 4 and this side is 2. This is telling me I have 2 rows and there's 4 in each one. I have 2 rows of 4. I can do the length times the width, and I can get the area. 2 times 4 is 8. Okay, so we can multiply to get that. All right, we're going to work on that this week. All right, let's take a look. I have another picture up here. Notice I have a square, and it says it's three units that way, 3 units this way. Well, if I drew the 3 units on here, it would look like this. 1, 2, 3. And now if I drew the 3 units coming across, 1, 2, 3. Look what happened. What did I end up making in the middle? I ended up making squares in the middle, right? So what those numbers are telling me is how many rows or how many columns I'd end up having on that figure. And it creates, when those lines intersect, they create squares in the middle, and that gives us area in the middle. To find the perimeter here, I'm going to add my way around, right? Every side on this is 3. So 3 plus 3, 6 plus 3, 9 plus 3, 12. So the perimeter is 12 units. How about the area? How about the area? We're going to count the squares where we could multiply them, right? What's 3 rows of 3? 3 times 3. That's 9. Now, remember, area, 9 square units. 9 square units. So, if you see these squares, you can certainly count them with area. But what we're going to eventually get to is where you have no squares there. You'll get a rectangle like this, and it will say that this side is 7 and this side is 3, and you're going to have to tell me the area. Well, this is going to make 3 rows, and there's going to be 7 in each one. Do you remember 3 times 7? Do you remember learning that last year? What is 3 times 7? How many squares would it make? It would make 21. So the area would be 21 square units. We'll get to that more later this week. Okay? How'd we do today for a Monday? Remember, what's the idea? What's the important thing? The important thing is that we grow, right? We want to grow from the beginning of the week to the end of the week. If you got some today, yeah! If you didn't get any, it's okay, because by the end of the week, we want to get more than what we had on Monday, right? Guys, keep working hard. I'm proud of you. See you tomorrow.